NVIDIA does not build artificial intelligence. It builds the infrastructure that makes artificial intelligence possible. Every large language model, every generative AI system, every autonomous application running at scale today, all of it runs on one platform. And that platform is controlled by one company. NVIDIA. Most people understand this as a chip story. A hardware company that got lucky with AI timing. That framing is incomplete. What NVIDIA built is not a product. It is a dependency. And understanding the difference is the key to understanding why this company is valued the way it is. NVIDIA is frequently described as a semiconductor company. That description understates what it has become. Yes, NVIDIA designs graphics processors. But the business is not graphics. The business is compute architecture. To place NVIDIA correctly in the value chain, consider the layers of the AI economy. ASML defines the physical limits of chip fabrication. TSMC manufactures advanced silicon. But NVIDIA determines how that silicon is organized to generate intelligence at scale. It operates at the execution layer of AI. The layer where models are trained, where inference runs, where the cost of intelligence is ultimately priced. And that layer captures extraordinary economic power. To understand NVIDIA's dominance, you need to understand the difference between a CPU and a GPU. A CPU is optimized for sequential tasks. A GPU is optimized for parallel computation. AI training is parallel by nature. Matrix multiplications, tensor operations, thousands of calculations executed simultaneously across thousands of cores. That alignment changed the economics of intelligence. The result is dramatically higher throughput for AI workloads, at a fraction of the time and cost of traditional processors. But hardware alone does not explain dominance. Software does. In 2006, NVIDIA introduced something called CUDA. At the time, the full strategic significance was not obvious. CUDA was a programming framework that allowed developers to write code that ran directly on NVIDIA GPUs. Not just for graphics, for any parallel computation. It transformed the GPU from a graphics accelerator into a general-purpose compute engine. Over the following decade, CUDA quietly became the foundation of modern deep learning, compilers, libraries, optimization tools, AI frameworks, all of them built on CUDA, all of them tuned for NVIDIA hardware. When the deep learning era arrived in earnest, the ecosystem was already in place. This is what created something far more powerful than a fast chip. It created lock-in. Switching away from NVIDIA is not a procurement decision. It is an architectural decision. It means rewriting workflows, retraining engineering teams, and accepting performance uncertainty during the transition. That friction is enormous, and it accumulates every year. NVIDIA no longer sells individual chips. It sells systems. Modern AI infrastructure is built on tightly integrated stacks. GPU clusters connected through high bandwidth memory. Advanced interconnect technologies like NVLink that allow chips to communicate at speeds traditional networks cannot match. Rack-scale systems designed for dense AI compute. With architectures like Blackwell and Grace Hopper, NVIDIA has moved toward compute platforms measured in racks, not components. This shift matters strategically. Components can be swapped. Infrastructure cannot be swapped without significant operational disruption. By integrating up the stack, NVIDIA made itself harder to displace at every layer of the system. NVIDIA's structural advantage rests on three distinct layers. The first is software dominance. CUDA and its ecosystem anchor developers before they ever write a single line of production code. The tooling, the libraries, the debugging environments, all of it optimized for NVIDIA. The second is ecosystem gravity. Startups build on NVIDIA because hyperscalers deploy NVIDIA. Hyperscalers deploy NVIDIA because the ecosystem runs on NVIDIA. The cycle is self-reinforcing and difficult to interrupt from outside. The third is integration depth. NVIDIA controls the optimization stack from silicon architecture through to inference deployment. That depth creates compounding switching costs that increase with every generation of tooling. These three layers together do not describe a temporary technological edge. They describe accumulated ecosystem leverage. And that kind of leverage is measured in years, not product cycles. The financial numbers reflect this structural position directly. In fiscal year 2025, NVIDIA generated over $130 billion in revenue. The majority came from data center and AI infrastructure. Not gaming. Not automotive. Data center. Gross margins exceeded 70%. These are not normal hardware margins. Industrial equipment companies operate in the 20s and 30s. Consumer electronics in the 30s and 40s. 70% gross margins are not a hardware outcome. They are a platform outcome. Hardware businesses compete on cost. Platform businesses compete on dependency. That distinction explains everything about how NVIDIA is valued. Demand is concentrated among hyperscalers and AI-native firms investing aggressively in compute capacity. This is capital expenditure on infrastructure. It is stickier, longer cycle and driven by competitive necessity, rather than discretionary preference. NVIDIA's position is not without structural dependencies. NVIDIA does not manufacture its own chips. It designs them and relies on advanced foundries, primarily TSMC, for production. This creates exposure to fabrication capacity constraints. When leading-edge supply is limited, NVIDIA's ability to fulfill demand is constrained regardless of order volume. It also ties NVIDIA's deployment trajectory to the global semiconductor roadmap. Advanced packaging, high-bandwidth memory supply chains, substrate availability. Each of these can become a bottleneck. NVIDIA's strength is ecosystem dominance. Its vulnerability is industrial dependence on a supply chain it does not fully control. If the roadmap accelerates, NVIDIA benefits. If supply tightens, deployment slows. That asymmetry is important to understand. Artificial intelligence has become a national security priority. Export controls have restricted NVIDIA's ability to ship its most advanced chips to China. Product variants have been redesigned to comply with these regulations. Further restrictions remain a regulatory possibility. This limits addressable revenue in a large market with significant demand. At the same time, governments across Europe, the Middle East and Asia are actively investing in sovereign AI infrastructure. Compute is now understood as a strategic resource. Nations that control leading-edge compute capacity have a structural advantage in AI capability. NVIDIA sits directly at that intersection. It is one of very few companies whose products are simultaneously essential to commercial AI development and treated as a national security asset by multiple governments. That is an unusual and consequential position. NVIDIA is not invulnerable. AMD continues to develop competitive AI accelerators. Progress has been real, even if the ecosystem gap remains substantial. More significantly, the largest NVIDIA customers are also developing custom silicon. Google's TPUs, Amazon's Trainium, Microsoft's Maya, Meta's MTIA. These internal chips are designed to reduce hyperscaler dependence on external suppliers for specific workloads. They will not replace NVIDIA across the board, but they represent a strategic effort to limit exposure. Regulatory scrutiny is increasing. Antitrust questions around ecosystem bundling and market position are beginning to surface. And capital expenditure cycles in technology are never linear. If AI infrastructure spending pauses or slows, revenue growth could compress sharply and quickly. The key question is not whether NVIDIA faces competition. It does. The key question is whether NVIDIA's position is structurally replaceable in a relevant timeframe. That question brings us back to software. Hardware can be replicated. Given sufficient capital and time, a competitive GPU is achievable. Ecosystems cannot be replicated quickly. 18 years of developer adoption, thousands of optimized libraries, deployment tooling embedded in production systems at every major AI company in the world. That is not a product. That is infrastructure. And infrastructure has a different relationship with competition than products do. As AI models scale, compute requirements intensify. As compute requirements intensify, platform dependence increases. The companies training the next generation of models need more of what NVIDIA provides, not less. NVIDIA understood early, that the value in AI would not be captured at the model layer or the application layer. It would be captured lower in the stack. It would be captured at the compute layer. And it spent nearly 2 decades building a position at that layer that competitors are now discovering is far harder to challenge than it appears. The deeper AI penetrates the economy, the more compute becomes the bottleneck. And bottlenecks concentrate power. In the AI economy, intelligence begins with models, but power begins with compute. And for now, compute runs on NVIDIA.